Hi everybody! Thanks for joining us tonight for yet another amazing Jackson Systems training. We're so happy to have everyone that was able to join us online, as well as our great audience here at our facility. We're going to do a lot of talking about zoning tonight. I have our good friend Elijah here with us. Come on in here.
I'm here.
Get a little closer. All right. He's going to be your trainer tonight. He's going to talk to you about how to diagnose issues while installing zoning systems. Any questions that you may have, send them through the live chat. If you're here in the audience, feel free to ask anything that you come up with. We are doing the training tonight a little bit differently. We're going to do it in two parts. The first part's going to be all the technical stuff, and the second part is going to be really fun. We're bringing in the owner of our company, Ron Jackson, to answer any questions that we don't get to throughout the training and any questions you come up with. Afterwards, whatever it may be, you can ask them live to Ron and Elijah, and should be some really great info. Enjoy the training. Elijah, let you take it from here.
Thank you. Good evening, everybody. My name is Elijah Montgomery. I'm a senior product engineer here at Jackson Systems. We're going to be talking tonight about zoning, some of the more technical aspects. So we're going to be talking about installation, some things you need to know about installation, some things to consider when installing a zone system or when planning one, and then we're going to talk about doing troubleshooting on a zone system. So if you get called in on a situation where you got a problem and there's a zone system in there, how do we deal with that zone system in context of a problem with the HVAC system? So without further ado, let's get going here. So your first step here, this is for any zoning installation. We tell our sales guys here in the office we have this 6-point checklist. We always make sure that you have ready when you're doing a zoning. Basically, the parts and components you're going to need for a zoning project. So number one, obviously, is the zone control panel. This is going to be the brains of the operation. Whether it's one of the I/O HVAC controls panels or Honeywell panel or whatever you use, you got to have something there to control the whole operation. Then you're going to need thermostats, obviously. So you're going to have a thermostat for each zone. You're going to sense the temperature in each zone and send calls for that zone so that each zone has its own temperature sensing. Next, you're going to need dampers. So your dampers obviously are going to get installed in the ductwork, and they're going to control your airflow into each zone. So you're going to need at least one damper per zone, in some cases more than one per zone depending on your duct layout. And that's something you'll have to check before you, while you're planning the zoning installation. You have to make sure you have a good handle on the duct layout, where the air's flowing, see if you might need multiple dampers per zone. Because you have to be able to shut off the air to a zone without shutting off any airflow to another zone. These two here, discharge air sensor and a transformer. So your discharge air sensor is going to, on most zone panels, is going to monitor your supply air temperature, and if you're bypassing air or if your pressure is increasing in the system, we're going to keep an eye on that discharge temperature, and if it gets too high or too low, the zone panel is going to be able to cycle the system off, let it cool off or warm up, and then back on again without hitting, for example, your furnace high limit or freezing a coil up. Transformer for the system, we always recommend installing a separate transformer for your zone system. Don't use the equipment transformer. This can prevent a lot of hassles and a lot of issues down the line, mainly because when you install a new transformer, you know what the VA rating of that transformer is, and you know exactly how much load you're putting on it. You don't have to worry about what else may be going on inside that piece of equipment. And then lastly, some method of pressure control. So you can't just hand wave it. We don't recommend hand waving it and assuming pressure is not going to be an issue. You have to at least look at it and address it. In some cases, you may not need to take any additional steps for pressure control. So for example, if you have a 2-zone system and the zones are pretty equally sized, and if the ductwork is a little bit oversized, if the ductwork's 10% oversized or so, you probably don't need to take any extra steps to manage the pressure. But anytime you're going to be closing off portions of your ductwork, you are going to have some pressure increase. And once it gets beyond a certain point, you're going to have noise. You're going to start to have more duct leakage. You may cause issues with your equipment. So you could use a conventional bypass, like these here you see here on the screen with the weighted arm, the barometric bypass dampers, with a bypass into the return, or some kind of a bleed-through system, like the IO ESP system, which is going to relieve air into non-calling zones, just enough to relieve the pressure. There's also other similar systems, like the Honeywell bypass, they're not bypass dampers, zone dampers, that have the fixed bleed through. They don't necessarily sense pressure, but they're going to have more of a fixed bleed through. There's a lot of ways to address that. But you do need to address it. You actually have to take it in consideration. If you look at it and you find, okay, I don't need to do anything special, I got an oversized ductwork, I'm going to be good with my pressures, then you're fine. But at least look at it. Don't just assume it's going to be fine. So we're going to go through some basic design considerations here. This is just kind of a list of things that we've put together over the years. Some of these may seem like they don't need to be said. But like the rule of thumb goes, anytime you see a warning sign somewhere or a warning on a package, no matter how stupid that warning sounds, chances are if that warning exists, it's because somebody did it. So that goes into play here. So first design consideration is good zone control starts with good HVAC design. So proper load calculations, proper duct sizing, proper equipment sizing is crucial. Just with any system, it's crucial. If you go in to install a zone system and you assume everything there is correct and you don't check it, you could be signing yourself up for a world of hurt, because if that duct size is not correct, if the equipment's not sized right, and you put in a zone system, if they then have any problem, whether it's your fault or not, in the eyes of that homeowner, it's your fault because you're the last one that touched the system, right? So do your homework, do your due diligence, make sure the system is sized right. Don't sign yourself up for somebody else's mistake. Here's one of these that sounds obvious. Install the thermostat in the respective zone. So whichever zone you're controlling, that zone's thermostat needs to be in the zone that it's trying to control, right? Again, that should go without saying, but you can't sense the temperature of the zone you're trying to control if your sensor, which is the thermostat in most cases, is not in that zone. So put the thermostat where it's going to be controlling air. Tag your wires. This is something that's probably seldom done, but is always recommended, and can save a lot of trouble down the line when you're pulling wire, when you're replacing systems or whatever. Tag your wires. Don't ever assume that the color of that wire tells you what it's connected to on the other end of that wire. All right? Just because it's a green wire doesn't mean it's connected to a G somewhere on the other end, unless you check it. You have to see it. So tagging wires is a good way to ensure that if you ever have to come back on a job and work on that job, it can make things a lot easier for you, or if somebody else has to, it can make things a lot easier for them. But tag and label your wires and zone designations. Zone dampers should be installed at least 10 feet from discharge air grills or registers when possible. So this is just to reduce noise. So anytime you put an obstruction of any kind in an air pathway, like a damper, it's going to cause some noise, right? You put an obstruction in airflow, it's going to cause turbulence, that causes noise. Even if it's a pretty low pressure, there's going to be some noise. The further you put that from the register, the less that's going to be perceptible, right? Your noise is going to be coming out of the register. It's already down. Oh, okay. So if your damper's too close to the register, then you could have some noise at that register, which is going to cause customer complaints. Even if it's not a problem for temperature comfort, or anything else, noise can be one of the first things that causes customer complaints. Zone dampers should be located where they can be accessed for troubleshooting. So obviously you can't control what a homeowner is going to do after you leave, right? So you install a bunch of dampers in a basement and 6 months later they come through and finish the basement and bury all those dampers behind a bunch of drywall. There's nothing you can do about that after the fact, but whenever possible, put dampers where they're going to be able to be accessed for serviceability, troubleshooting in the future. Our dampers are pretty good. They're going to last a while, but they don't last forever. Someday, someone's going to have to do something with that damper. So try to leave it where you can get to it. That picture there is actually in our sales office, so you can see that nice flue pipe right there in front of that damper. So if you ever have to get that damper out, you're going to have to disassemble that flue pipe to get to it. But that's better than some I've seen. What else? Thermostats and zone dampers can be located usually up to 300 feet from the control panel with standard 18 gauge wire. That's a pretty standard thing. Always use separate 24 volt transformer rated at the proper VA to power the panel, dampers, and zone thermostats. So typically your zone system transformer is going to be powering your zone dampers, your thermostats, and your zone panel. So you're going to want to make sure it's properly rated for your total load. The biggest part of that is your dampers. You want to make sure, keep a close eye on what kind of dampers you have and what their draw is in terms of VA to make sure you don't overload that transformer. Dampers can vary quite a bit in terms of their rating. So standard 2-wire dampers, these IO 2-wire dampers here have pull 10 VA each. So if you're only using a 40 VA transformer, you put 4 of these on a zone system, you're tapped out. 3-wire dampers with the Belimo actuators only pull 2.5 VA each. So you can those are a lot more efficient in terms of their electricity usage. You can put a lot more of those on a system or on the same transformer before you run out of juice. So keep an eye on that when you're planning it out. If you do need to exceed your total VA, typical VA limit are 30 VA per zone. If you do need to exceed that, you can if you have to. You'll have to use isolation relays and in some cases an additional transformer just so you're not running all of that current through the zone panel. Basically, you just send the current around the zone panel and through the relay instead. Never use the equipment transformer regardless of its VA rating. That's just a standard rule of thumb. We always recommend just always install a separate transformer. Most zone panels have electrical isolation, dry contacts between the panel and the equipment, so you don't have to worry about having separate transformers. You don't have to worry about any phase issues there or anything. So just always install a separate transformer, and you don't have to worry about what kind of load you're putting on that thing. If you're using a bypass damper, make sure you size it right. First of all, this is a damper sizing. This is just a general rule of thumb. Basically, any zone system, you subtract your smallest zone's CFM, and the remainder is how much CFM you need to be able to bypass. You can bypass it at a higher pressure. We usually allow pressures to go up to 0.35, 0.4 inches water column. But if you need to calculate it out, you can do that. This is a rule of thumb chart we use typically in terms of tonnage, 400 CFM per ton. All right, moving on. So we're going to talk about some of these zone panels. And if you guys, all you guys should have some zone panels on your tables there. For the folks watching remotely, sorry, we don't have zone panels to send out to you just for this. But the guys here in the office will get a little bit of hands-on. You guys all have screwdrivers? Mike or Bill, if one of you guys can go out here, there's some screwdrivers on the table right here. You should have a little plug-in power supply there, or plug-in transformer. You can go ahead and wire it. Feel free to wire that up to your hot and common, and you should all have a plug-in pretty close by that you can use. So we're going to be using, as an example, the IO HVAC Controls ZP3 HPS panel. This is the 3-zone heat pump board. So the first thing here, I have a list of its features. The main reason I have this up here is because when you're working on a zone system, when you're installing it, or when you're doing troubleshooting on a zone system, it's important to understand what that zone panel does and what its sequence of operation is. The sequence of operation is going to help you understand as you go through and do troubleshooting. When you do a step, is the system behaving like it should? So you go through and you systematically do troubleshooting until you find out what doesn't match up, right? So, for example, this board it'll do up to 3 zones. It'll do multi-stage. It has auto changeover, so if it receives heat calls and cool calls, or heat calls from one zone, cooling from another, it can interpret those and knows what to do with those. Compatible with all your standard thermostats, works with 2 or 3-wire, 2-position dampers, has short cycle protection built in, so there's some time delays. Has a 60-second purge option, and also has dual fuel control options. So let's go into basically what you're going to see when you wire it up. So this is the wiring setup of a zone system. So in this case, it looks like we got 2 zones wired up, very similar to my demo board I have right here. So your zone 1 damper and thermostats are going to be up on the top. So wire zone 1 thermostat and damper into the zone 1 terminals. Again, this sounds straightforward, but you'd be surprised how many times people switch those dampers or wire the wrong damper to the wrong zone or whatnot. So, so you're going to wire your thermostats to the zone panel and your dampers to the zone panel. Like I said, these panels and a lot of panels now can take either 2 or 3-wire dampers. Your standard 2-wire zone dampers are power closed, spring open. So you'll use the power close and common terminals on the zone panel to do that. If you're using 3-wire dampers, should be labeled power close, power open, and common. So those are the 3 wires you're going to use there. On the right-hand side of the board, on these boards, IO likes to put a lot of LED indications on their zone panels. So when you power them up, and you guys can feel free to find a plug, an outlet nearby, or if you need an extension cord, we can get you one. So feel free to plug those in. You're going to see some lights light up on the side. So when there are no calls, typically all your zone dampers are going to go open. It should reach that orange one there. So all your zone dampers are going to go open. On this board, the green light for the zone damper indicates that damper's zone that zone's damper should be open. So when you first power it up, you should see 24 volts at the top to indicate that the board has power, and you should have all 3 zone damper LEDs lit. That tells you that you have power and all of your dampers are open. Until you get a call, you shouldn't have anything else going on. Also, if you have a discharge air sensor installed, which you should if you're installing a new system, on these boards your limit light will light up solid. If that limit trips while it's running, it'll be flashing. But if it's lit up solid, that just tells you, okay, it sees a discharge air sensor installed. So again, your damper LEDs, ZD1, ZD2, ZD3 on this one, indicate that zone damper is open. When there are no calls, all dampers are open. When we get a call, let's see if we can get a call going here. There we go. So when you get a call, the appropriate lights should light up on the board. So in this case, I have this is a heat pump board set up for a B-type reversing valve. So I have a Y1, that's not right. So that thermostat's probably not set up right. So I have a Y1 and I have a G call on my board. Those LEDs should match the relay output of the board, the signal going out to your HVAC system. So, so you can always check your outputs and make sure they match your LEDs. If there's a mismatch there, you may have a problem in the board. And we'll go through here in a little bit how to go through and check that. But that's your basic sequence of operations. So when a zone calls, the board sees that call, says, okay, we're going to send that call through. It'll pass that call through to the equipment. open the calling zone's dampers or leave it open, and then the non-calling dampers, it'll power closed. All right, so only the zone that's calling is going to get the conditioned air, the heated or cooled air, whatever it is. All right, that's your basic sequence of operation. There's some other things in there in terms of how the panels handle conflict between different zones or even within one zone. So if a zone gets, for some reason, 24 volts in on the W and the Y, and it's a heat-cool board, so the board sees that as getting a heat call and a cool call at the same time, right? That could happen if you have a short between some wires for some reason, right? So if that happens, most boards, these boards I know, will completely ignore that call. If it sees a conflicting call coming in on a single zone, it's going to say, I don't know what to do with that. I'm just not going to do anything. So it's always important to check the places you do expect to see voltages and the places you don't. I'll get to that in a second too. But that's your basic sequence of operation. Anytime you're doing troubleshooting on a zone panel, it's important to understand what that basic sequence is, all right? You got to know what it's supposed to do so you can figure out, okay, at what point is this process breaking down, right? Your signal should go from your thermostat to the zone panel and then to the equipment. So if your thermostat's calling for cooling and your system's not running cooling, something in there is not working, right? And you just got to break it down and figure out what that is. So, so for troubleshooting, we always like to isolate things, all right? So you want to test each component of the system in isolation, all right? So you got to know what each part of the system is going to do. So when a thermostat calls for cooling, for example, it's going to close a relay internally and send out 24 volts on its cooling wire, usually a Y. So that's what you expect to see. So you can check for that. So you want to make sure each step of the line is having the proper signals transmitted, right? So you want to make sure your thermostat's sending 24 volts to the board. If you verify that, you can verify if the board sees that signal and make sure the output's correct. Also, don't make assumptions. All right, don't make assumptions. I can't emphasize this enough. So double check your terminal wiring. What did I say earlier? Just because you have a green wire, don't assume that's connected to a G on the other end, right? Just because you have a white wire, don't assume that's connected to a W on the other end. You got to check. Double check and double check. Also, when you're checking for voltages, you're making sure, hey, I've got this voltage here, I got this voltage here. Check everything. All right, don't just check the terminals you expect to see voltage on. Check the terminals you expect not to see voltage on, right? You want to make sure you have voltage where you expect to see it and don't have voltage where you don't expect to see it, right? So check everything. And then lastly, understand the basic sequence of operation and look for inconsistencies. So one thing that comes up a lot on these panels I know, so these panels are double fuse protected. One thing that happens a lot is people will call in and say, hey, I've got fuses blowing, all right? It's important to know which fuse is protecting what, all right? So on the left-hand side, you have the zone system fuse. That fuse is on the incoming transformer, the 24 volts AC, powering the zone panel. It also powers the dampers and the thermostats. So if that fuse is blowing, you can safely ignore these connections over here. The ones going to your equipment and your equipment, that's not the problem if your zone system fuse is blowing. Vice versa, if your HVAC equipment fuse, that fuse right there is just on your hot wire coming in from your equipment. So if that fuse right there blows, you can completely ignore your dampers, your thermostats, everything in the zone panel, all right? So if your HVAC equipment fuse is blowing, it's not the zone system. It's not the zone system. I would bet money on that. Almost always, this is blowing because it's got a slightly lower amp rating than the fuse in the equipment. And if we just shorted right across there and just jumpered across that instead, or had a higher rated fuse in there, you'd blow the fuse inside your equipment. But if that thing's blowing, it's some issue in these wiring here or something internal in your HVAC equipment. So if you're tracing down issues here, you're going to step by step go through and do troubleshooting. So one, you want to make sure, and basically with these panels and with pretty much any zone panel, you can do almost all your troubleshooting just with a voltmeter or multimeter, sorry, and some jumper wire. These magnetic jumper wires are super handy if you don't have those. So the first thing you want to do is check your thermostat voltages. So we've got this zone 2 thermostat still calling. So I'm going to check my volts AC here on zone 2 from common. And I'm going to start, and like I said before, I'm going to go right down the line, check everything. So the first thing I'm going to do, C to R, make sure I've got voltage there. I've got 27 volts. And then I'm going to go to W. I have no voltage there. That's good. I'm going to go to Y. 27 volts there. Y2, I shouldn't have anything. There's not even a wire connected there. Nothing. O, I've got, no, that's G. G, I've got 27 volts. And my OB, I have no volts. So that's the first thing you're going to check. Make sure the right signals are coming in from the thermostat. All right. If you're not getting the right signals in, if your thermostat says it's calling for cooling, but you don't have a Y signal, okay, well then you need to take a look at the thermostat side of things. It could be a broken wire somewhere between your thermostat and the zone panel. Could be a problem with the thermostat itself or the thermostat subbase, some loose wire connection at the thermostat subbase. But if you're not getting the right signal from your thermostat, then look at your thermostat side of things. If you verified that, you've got the right voltages there from all your thermostats, you can then double check your board. So with any zone panel, you can always simulate a thermostat input. So you can take the thermostat, if you're questioning your wiring, if you're questioning your thermostat, you can always just take that completely out of the picture and simulate a thermostat with some jumper wires. And this is what we do with the panels here when we test them. You can just jumper. So if I want to, let's turn this one off. All right, so I've got no zones calling. So if we just jumper from my R, where my 24 volts is, to my G, then I've just simulated a fan call on zone 1. All right, so if I jumper that, I know I should get a G LED come on, zone 1 LED goes on, the other 2 zones go off. All right, if I get that behavior and I do the same check on each of the terminals on this thermostat and on this entire side of the board, I know that my zone panel is properly recognizing signals coming in. So I know at least my input detection on my zone panel, there's nothing wrong with that. Could be something else in there, but at least it's seeing, I know that it's seeing the inputs, right? There's other ways some panels do it, like this Honeywell panel, this 432 here, actually has a checkout mode, which is pretty neat. If you jumper over there, it'll actually tell you what inputs it's seeing right there. It'll just like spell it out there for you. It'll say Y1, Y2, G, whatever. But you got to know how to check it out. But on most any panel, you can do that. Simulate a thermostat input and see if it behaves properly. See if it reacts the way you expect it to react. If it doesn't, the problem may be inside the zone panel. But in a lot of cases, it's not. And the reason we started doing this training is because not too long ago, a year ago, we were getting, I'd say 75% of the zone panels that were returned to us as defective under warranty. We tested them and there's nothing wrong with them at all. Thorough testing, troubleshooting of zone panels can save you a lot of time and trouble in the field. So we tested our thermostat inputs, and we can also simulate thermostat inputs with some jumper wires. You can also, if you have issues with dampers, check your damper outputs. So if the concern is, okay, this doesn't seem like I'm getting airflow here, this damper doesn't seem to be opening, it's typically pretty straightforward to check that. We usually recommend checking your damper outputs from the zone panel with the damper disconnected from it. At least checking it first that way. The reason being, some dampers, some damper actuators will actually produce a feedback voltage, and you'll see voltage on both sides, right? I know the one I'm most familiar with that does that, most Siemens actuators will show that. And if you wire up dissimilar actuators you have, if you wire a Belimo actuator in parallel with a Siemens actuator, the Belimo actuator it's not like that and will not behave properly. But it's just a phantom voltage. There's not really any current there. So we always recommend first check your output with the damper disconnected. That way you can be sure that your zone panel is outputting the proper voltage, right? The voltage you expect to see. If it's not, it's usually pretty straightforward. Your damper LED should match your output. So a green LED for the zone on this board indicates damper open, all right? So if you have a green LED, you should see 24 volts on your power open and no volts on your power close. If the LED is out, you should see 24 volts on your power close and no volts on your power open. If you're getting the correct output but your damper's still not working, then I'd go down to where your damper is and actually check the voltage at the damper, make sure it's getting the right voltage there. Make sure there's not a broken wire somewhere there, or you got some loose wire nuts maybe. And last case, if you suspect your damper actuator may be bad, you can always just get 2 wires straight off the transformer and just put 24 volts straight to the damper to power it open, power it closed, see if it moves. If it doesn't, you probably got some issue with the damper. But again, it breaks down to just break the system apart, test the individual components on their own, know what to expect. What do we got here? Lastly, we got our outputs. So outputs on this board are dry contacts to avoid any kind of phase issues between the equipment transformer and the zone panel transformer. So we don't have a common wire there. We just have relay closures, open, close. So we typically don't recommend people check your equipment outputs using the voltage setting on your multimeter. The most reliable way to do that is to disconnect the wires going to your equipment, switch it over to continuity or tone or resistance, and just check your outputs. So let's get an output here. There we go. So if I go from R, basically I just want to check for continuity between each of my terminals to see what's open and what's closed, right? So if I go from R, W, nothing. Y1, I got tone, nothing Y2. G, I got tone. OB, I got tone. And that should match your LED indication. So if the panel says these things are being called for right now, that should match exactly your relay outputs. If they don't, there's probably something wrong with the board. It could just be the fuse. If your fuse is blown, you're not going to have any continuity there, right? Nothing's going to have continuity if your fuse is blown. So if you don't have continuity there, first thing to check is your fuse. If your fuse is intact, then you may have a problem with the relays. The relay contacts may be blown in there or something like that. But that's how you're going to check your outputs. So continuity to check your outputs, voltage to check your thermostat inputs, voltage to check your damper outputs. And then the last thing to check sometimes that comes into play is if you need to check your sensors. So on the heat pump panels, there are outdoor temperature sensors, and heat pump and heat cool panels will typically have discharge air sensors. In a lot of cases, those are standard 10K ohm sensors or 10K thermistors. So you can check those with the resistance setting on your multimeter. So disconnect them from the panel to do that, but you can check the resistance there and see if it falls within range. Typically, thermistors like that are not going to fail in normal operation, and they're not going to run out of calibration. Okay, so when they do fail, they typically will fail to a full open or or short, right? But they're not going to drift typically. They don't run out of calibration, or we don't really see that. If they fail, their failure mode is usually an open or closed. But you can always check that with the resistance setting on your multimeter. I ran through that really fast. Anybody have questions on any of that? No? Okay. That was faster than I expected. That's pretty much all I have for the first part of it. So, Jillian's going to come back up. We're going to do a little Q&A.
Okay, so we have some questions that came in throughout the day today through a survey that we asked. So we're going to run through those, and I have a couple of questions that came in through the technical training, and we will also address those. If you have any others as we go through this, please feel free to ask anyone here. Throw some good ones at us, whatever you got. If you haven't met Ron, or if you don't know who Ron is, he's the owner of our company, and definitely wealth of knowledge in the zoning realm. So I always like to try to stump him. He's pretty hard to stump, though. So I'll let you guys take it. I'll go ahead and pull the questions up.
All right. I'd like to second the motion on, please interrupt us, ask more questions. Getting that interaction going is really, we get an awful lot out of that. You'll get an awful lot out of that if we have some dialogue going back and forth. So those of you in the room, even some of our own people, ask some questions.
Okay. You guys ready for these?
Bring it on.
All right. So we're going to start with a question from Paul. This question came in through the day today. And he asked, how do you keep an electrically controlled static pressure system from fighting a variable speed fan?
That's a great question. We get that a lot. And Ron and I were actually talking about this earlier today. So the first thing we agreed you need to talk about is defining what you mean by a variable speed fan, because there's actually quite a few different things that people mean when they say that. So the question we get most often is how do you deal with ECM blowers? And I'd say most cases what we're talking about is systems that have different fan speeds that will ramp up or down depending on what kind of call is going on, right, Ron? So you may have no call, fan only, heat stage 1, heat stage 2, cooling stage 1, cooling stage 2. And they all may have different fan speeds, right? So if that's the case, that's going to be a fan speed controlled internally within the equipment. Most zone systems are only going to have a single speed fan output. A few have maybe like a high speed output, so it could kick it into a high speed. But for the most part, the zone panel is just going to output a single speed fan, just like most thermostats do, right? So that's going to be handled internally within the equipment. Doesn't really affect the ESP system much at all, because the ESP is going to react to the static pressure. So as when it goes into cooling, for example, when it's running cooling stage 1, the fan speed is really not going to be changing once it's running cooling. The ESP will react to the pressure, whether it goes up or down, regardless of what the system's doing. So the only time it would really become an issue is if you had a true variable speed system where you had some kind of pressure control or something within the equipment that's going to possibly change the fan speed on the fly in reaction to static pressure. If you have a system like that, and those would be probably like a Carrier Infinity system or something like that, there's some others. The first thing you want to be sure of, and like one of the points I mentioned earlier, is address the pressure situation. If you've got a variable speed fan like that, there's a pretty good chance that the fan itself might be sufficient to deal with your pressure, right? So you may not need any extra pressure control measures if your variable speed fan can drop the pressure enough and maintain the pressure enough on a minimum call, right? If that's the case, then you're probably fine. But I'm guessing that's more seldom than we even think.
As Elijah pointed out, we get this question all the time. And literally in the last 25 or 30 years, when we started first doing zoning, that I was concerned in the beginning. I don't ever recall having a contractor call me up and say, you indicated there shouldn't be a problem. There is a problem. I don't know of a single case after thousands of panels and systems out there. So when they refer to variable speed, they're not generally talking about variable speed the way Carrier with their modulated system or Train with their modulated system. That is true variable speed, even though we're varying the speed for several different reasons with some of the most basic type equipment. I know in my own home, if there's no calls, you're on the slowest speed. If there's a call for heat, you're on the next highest speed, and then the next highest speed. And the big advantage, of course, with ECM motors is that change occurs very slowly, and therefore the homeowner's doesn't notice it. And not only that, the ECM motor, of course, is very efficient. So you get a quieter system. You get it's better all the way around, and of course a much more efficient system, as I just said.
That was good. Those were great answers. That was a good question, though, too.
We get that a lot.
Okay, so we'll move on to one of our live questions here, and this question comes from Robert. And he asked, what does the panel do with a call for AC on zone 2 and a call for heat on zone 1? Do the boards use priority?
Yeah, every board that supports auto changeover is going to have some kind of priority. Different boards are going to handle it differently. So the ZP3 HPS, for example, one has a first call priority. So whichever call comes in first is going to get the call. But they should all have control measures in to prevent cases where there may be a stuck call or some kind of issue. So, for example, that board has a 20-minute timeshare. If the system's running one mode continuously for 20 minutes, say cooling only for 20 minutes, and it's still not satisfied, if there's an opposite call, it'll shut down the cooling and switch over and run heating so that other call gets satisfied. On the smaller panels, that shouldn't come up unless there's some kind of malfunction or some kind of error. I would think. I wouldn't expect to see a single zone calling for cooling for 20 minutes straight too often. But on larger panels, if you get to 6 zones or more where you got an office, and you may have multiple zones calling and satisfying while other zones are calling and satisfying, right? So even though no one zone may be calling for 20 minutes nonstop, the system itself could be running for 20 minutes as calls come in and drop out, right? So on a commercial building like that, it could be more common.
At the end of the 20-minute cycle, the system takes a look to see if there are any calls for the opposite mode. If not, it just keeps right on going. Only if there is a call does it switch over to the opposite mode. So it's so you can have, if you're running more than 20 minutes and you haven't satisfied, there may be some other issues, but having just as a point of interest, that's the way it works.
But
yes.
any panel that supports auto changeover should have some kind of priority, whether it's a fixed first call, majority wins priority, it could have options, could be a cooling priority, things like that, could be selectable.
Is there any indication, like, not especially, I don't see any lights on here that says that it's actually in that sharing mode? Is there a good way to tell, like, if I walked up in a place and it says, they're saying, well, I can't get my upstairs down to below 79
There's not a, so the question is there an indication on the board that it's in that sharing mode or that's seeing multiple calls like that? On these boards, the IO controls boards, there's not. The only way you could know is again to just verify the inputs and okay, yeah, the board's running cooling, but I got a heating coil over here, so obviously that's what's going on. But that's the only way to tell on that. Some other boards may have some indication of that. I think that the HC432 from Honeywell does something like that. It's got a little bit more fancy indication with its LCD display.
Get that answered for you, okay? Good?
Go ahead.
Good.
When you said verify, you go to the zone.
Yeah,
see
just
if
look
you
at your
got
look at
power
your
on.
inputs. Make sure you got your inputs because there's
You got
know.
two inputs, okay.
Yeah, I mean, there's two if a thermostat's calling and the system's not responding to that call, there's two possibilities. Either there's some reason the panel's not responding, maybe there's an opposite call, or it's not getting it. So make sure that voltage is there. But yeah, on these panels, that's the only way to know.
Okay. So our next question is one that came in through the day. It's from Hector. And he asked, would you zone a single stage and a multi-stage system differently?
Simple answer, no. That's an awful basic way to put it, but do you want to make additional comment on that?
Yeah, I'll make a little bit more complex answer. If you have a multi-stage system, particularly if you have a larger system with more zones, there are some panels that have more staging options that may give you a little bit better control over your staging in your system than a basic panel like these 3-zone panels would. So, for example, the large I/O controls panel, the ZP6, has capacity control. So you can set it so that it won't allow upstaging until a certain number of zones is calling, right? Because if you got a 6-zone system, you may not want one zone thermostat to kick on and kick the unit all the way up into high stage, right? So you may want 2 or 3 zones to be calling before you allow it to upstage to your high stage. So there are options like that, other kind of stage timer options and things like that on some panels that you may want to look at if you have a multi-stage system, if you need that kind of control.
Given a choice, always opt, especially in the heating, for 2-stage heating. It costs so little, and it greatly improves the whole zoning process. As you're aware of, you may only, depending on how many zones you've got and everything, only one zone may be calling. And if only one zone's calling, it's really nice to have that on low fire. The temperature control will be improved. It's just the right way to do it if it fits the budget. I wouldn't think of, for my own home or whatever, would not ever consider not having 2 stages on heating. If cooling gets a little expensive with 2-stage, but if it fits somebody's budget, once again, it's truly the right thing to do.
Okay. Our next question comes from Ferris. And he asked, when can a 2-wire damper be better than a 3-wire damper, if ever?
So 2-wire dampers, the main reason you might use a 2-wire damper in a zone system is just cost. 2-wire dampers are a bit cheaper than 3-wire dampers typically, and you only need 2 wires. So if you've already got 2 wires there and you don't want to have to pull a 3-wire cable or a 3rd wire, that can save you some money there on installation. Outside of zoning in particular, the one area where we would use 2-wire dampers is any area where you definitely want a spring return action. So frequently we'll use power open spring close 2-wire dampers for like outside air applications where we want it to always spring close because we don't ever want to just leave that damper stuck open.
Another advantage to the 2-wire damper is if it should fail, it's nice to have it fail to the open position. But I think the 3-wire, the advantages over with 3-wire dampers would cause me most of the time to encourage using the 3-wire over the 2-wire, even though the 2-wire does have a few advantages, as Elijah just pointed out.
3-wire motors typically are a lot more efficient. The Belimo 3-wire actuators are fantastic. They're phenomenally reliable. They're really efficient. They're quiet. They're great motors.
And if the damper's a little warped because somebody stood on it, that motor's
They have more
powerful enough.
torque
It
too,
keeps
yeah.
it has a lot more torque, so it just you're not gonna stall the motor. Where most 2-wire motors, since they're spring return, it's not easy to stall them, but it's a lot easier than, well, typically the 3-wire motor has 5 times the torque of a 2-wire motor.
Okay. Any questions out here in the audience at all? People that are actually here with us or anyone online, let us know. I have a few more questions for you.
Okay.
Good.
This question's from Sandy. And question is, what are your thoughts on compressor overrides using a discharge air sensor? Is it bad for the compressor?
So I saw that question earlier, and I'm not 100% sure I know what she means. I am assuming they're talking about the blow limit setting on the zone panels with the discharge air sensor. If you're cycling the compressor off, as long as you're doing it through a system that has some time delay in it and built-in short cycle protection, which the zone panel does, there's not really reason to be concerned about that. If you were to just hook some kind of open-close temperature sensor to it and hope that that's going to, and just wire it straight in series, that could be setting yourself up for some trouble. But if you do it through a zone panel or some kind of controller that has time delays and short cycle protection built in, there's no reason to worry.
Okay. All right. So our next question comes from Robert.
I'll take that one.
Are you sure? Are you sure?
Yes.
All right.
I'm just teasing. Go ahead.
He asked, if I zone the supply ducts and don't zone the returns, will I be depressurizing closed door rooms?
I'm going to answer that a little bit different than the way the question was asked. I only know of one case where return air dampers were installed. That was in my home. And it really can make sense, but because of the expense, nobody wants to do it. If you have an upstairs, everybody knows warm air is going to rise. So if you have return air, there's no question that some of the warm air that's rising will be pulled into those rooms, and if that happens and you're doing setback, you're not going to get as aggressive a setback. I had a 2-story home. I wanted to get the most aggressive setback, save the maximum amount of money. I didn't want to close the doors. You can close the doors and accomplish the same thing. So I put a return air damper in because it was easy to do because the 3 bedrooms upstairs were served by a single trunk line. And so if the zone upstairs is not calling, then I would also not only just the zone damper that's controlling the discharge, but also in the controlling, I put a return air damper in. Now I'm not going to pull any warm air back into those rooms, so I'm going to, instead of maybe, if I want to get down to 60 degrees, I can do it. Otherwise, maybe the best I can do is 65 degrees. It's hard to say. Every home's different, but it is a good solution if the budget can stand it. Got any comment on that?
Yeah, I mean, just my only thought on the question is, will it depressurize the room? I mean, a little bit. Every return grill should have at least a slight negative pressure to it, right? So yeah, you're going to have a slight negative pressure to it. It's not going to pop your ears or anything, but it's going to have a slight negative pressure. If you put your hand by the closed door, you may be able to feel air coming through there. You probably will. Is it going to cause any kind of problem? Probably not, because the air is going to follow the path of least resistance typically, right? So if you got a door closed with a return in there, there's not going to be much air going through there. Most of the air is going to be coming from the returns that are wide open.
All right. We do have a question online from Ronald. And he asked, how well does zoning work with ducted inverter equipment where capacity is ramped up and down?
How well does zoning work with ducted inverter equipment? So,
And I will say, he did specifically mention an interest in zoning a Bosch IDS equipment.
okay, so I'm not familiar with that particular piece of equipment. However, all of the inverters that I know of all use some kind of proprietary thermostats and some kind of whether it's communicating or not. They're typically proprietary, whether it's a Daikin or Mitsubishi or whatever. Which basically any kind of third-party zoning, like these I/O controls or a Honeywell or something like that, basically throws that out the window. Can't do it. If it's an inverter that has conventional inputs, like your YWG type inputs, then yeah, we could zone it. But if it's proprietary controls, proprietary thermostat or whatever, there's not much we can do with a third-party zone system.
Those proprietary guys just do not play well with others, do they?
I know.
It's not very nice.
No, it's not.
All right. So we have a question from Harvey, and he asked, is there any reason to not use dual ESP400 units on a single FAU? And I believe he's asking about a 7-zone system. And he also, kind of second part here, if dual ESP400 is okay, would design require dual pressure sensors, one to each ESP400, or can one pressure sensor wire to both?
I think you ought to tell them how ESP works first, because
Yeah.
we have not addressed that at this point.
So first of all, so what he's asking is, so the ESP system that the I/O HVAC controls boards have, not this one here, but some of the newer generation of boards, have a static pressure sensor that wires to the zone panel. And when the static pressure exceeds whatever the set point you have set on that static pressure sensor, the panel will drive your non-calling zone dampers open just a little bit in order to relieve static pressure through the non-calling zones, allowing you to install the zone system without a bypass. The first version of that system wasn't integrated into the zone panel. It was actually a standalone board called the ESP400. And I'm talking about this like it was a long time ago, but it was last year. We developed this pretty quick. So the ESP400 is a standalone board that basically allows you to wire in the static pressure control and run your damper wiring through it to your dampers, from the zone panel into the ESP board and then out of the ESP board to your dampers, so that it could basically intercept and override those damper commands. So with a 7-zone system, it is possible. I think the way he asked it was actually, is there any reason not to, right? So it is possible. You can do it. You can install 2 ESP400s because they're 4 zones each. So if you have more than 4 zones and you need more than 4 zones of ESP control, yes, you can do it. Is there a reason not to? Yes, it can get very complicated with the wiring. You got a zone panel, you got 2 ESP panels, you got a static pressure control, you got all the damper wiring. It can be a real mess. So if you're going to do it, just be aware it could be complicated.
The best way to do it, of course, is to buy a panel that has that all built in. Then it becomes a no-brainer.
Yeah, the ZP6 panel, ESP panel has, we can do 6 zones with the ESP built in, and there's actually expansion panels coming for that soon, which will allow us to do up to 12. But if you're using the separate ESP boards, you can do it. Special considerations with that: when you're using the ESP, you would use only one static pressure control, and you would just wire that static pressure control to both ESP panels in parallel, making sure to keep the polarity of those wires the same between the 2 panels. And it's also important to make sure that you power the ESP panels from the same transformer you're powering your zone panel from, and you keep the power, the 24 volts AC polarity, the same between your zone panel and both ESP panels.
So if you don't, you'll know it pretty quick.
Yeah, like I said, it's a little complicated, but yes, you absolutely can do it.
Okay. Awesome.
And we have a drawing that will show you how to do that to make it easier.
We have special application wiring diagrams that will actually show you.
It makes it a little easier, but you're using a lot of real estate as you have all these individual panels, and sometimes there's not enough room. But when you can't put in a bypass, it makes a lot of sense.
Yep.
Awesome. Any other questions out here in the audience at all? Anybody? No? I think we got all the questions.
Is that it?
If anybody online wants to Give you just a second here. Throw in any others. Is there anything else you would like to add while we wait a couple of seconds here?
I think I've said all I have to say. I think we covered it.
Oh, that was a lot of help, guys.
What are you supposed to do now, huh?
Do you know any good jokes?
Yeah.
No? Okay. All right. So we'll go ahead and tie this up here, guys. And I do want to mention one thing, and hopefully you can attest to how awesome our virtual app is, Elijah. Do you want to talk about that a little bit here?
Do you want me to talk about it?
Oh, I can.
Why don't you
Let me
talk
talk
about
about it.
Why don't you talk about it?
I got
Here,
this,
why don't you sit in
guys.
the chair?
All right.
You're good.
No,
Sit
I like
down.
to stand.
All right, have a seat.
All right. All right. So what I want to talk with you all about is you obviously got a ton of information today. If you're not familiar with zoning or you're really familiar with zoning, whatever it may be, if you're out in the field, Jackson Systems has you covered in a new way through our virtual app. If you download the Jackson Systems app and push the little round button on it, if you have a question while you're in the field, you're going to get this guy or someone somewhat like him, maybe a little better looking, who knows, that will be able to answer your questions in the field. You can show us exactly what you're looking at. Anything that you come up with question-wise, it really cuts down on the amount of time that you have to spend explaining what you're looking at, and we can answer your questions much quicker and much more effectively. So download that app, Jackson Systems app. It's really easy to find. Shoot Elijah a call on it anytime. He's happy to answer any questions. Any product you get from us, we will technically help you out on. Anything you need.
We'd really like to encourage you, almost insist, don't fight the problem in the field. Pick up that app or whatever, or the phone, and call us, because we're really very good at supporting these products, since many of them were developed by me, I guess. So that gives us a little bit of a head start over the competition sometime.
Absolutely. Something to mention here is no matter if you use the app or call in for technical support, you're just going to get a live person. Rather, you can see them through the app or hear them on the phone. We're not going to send you to an answering service. Lord knows we hate waiting 20 minutes to get someone live to ask a simple question. So
we have one more question coming, actually.
Actually, I got that one, and I will let them answer that one. Yep.
Perfect.
We'll actually answer that one offline.
Gotcha.
Okay?
What's
Any
the
other?
name of that app?
The virtual technician.
What's the phone number?
In the App Store, it's just Jackson
It
Systems.
is in the App Store. You just search Jackson Systems, and it'll pop up. Any other questions, Justin? Anything else?
Yeah, what was the phone number to call into?
I'm about to give my cell phone number right now because I currently cannot think of it, but I won't.
There it is.
There it is. It's on the screen.
There it is. We found
It's
it.
a little on the screen, but it's there. 888-888-652-9663.
That's
All right.
for troubleshooting.
That's for
Yeah.
anything.
For anything.
If you just want to call in and talk to us through it, ask us about our day. We'll always talk to you. Whatever you need us for. We good, guys? Any other questions? Did read it's supposed to be record heat this summer is what's being predicted. So think of us for any needs you may have. We're here to help you, and we look forward to working with all of you. Join us again on our next training. Thanks.
Thanks for watching the video. Be sure to smack that like button below. And if you want notifications on brand new videos that are coming out tailored just for you, be sure to subscribe right here to the Jackson Systems YouTube channel. Now, if there's some videos you missed, you can always check it out right here. Go ahead and click subscribe. Other videos, like, do it.